Hello everyone, and welcome to today's tutorial on solving the remove duplicates from sorted array problem on LeetCode. In this tutorial, we will explore an efficient algorithmic approach to solve this problem using the power of Python programming. The problem at hand is to remove duplicates from a sorted array in place while maintaining the relative order of the unique elements. Our goal is to find a solution that not only produces the correct output, but also has optimal time and space complexity. The solution we will explore is based on a powerful technique known as the two-pointer approach. This technique is widely used to solve problems that involve manipulating arrays or linked lists efficiently. By understanding and applying this technique, you will not only solve this specific problem, but also gain a valuable problem-solving strategy for similar scenarios. Throughout the tutorial, we will discuss the intuition behind the solution and explore how the sorted nature of the input array can be leveraged to optimize our solution and achieve a linear time complexity of O of n and constant space complexity of O of 1. And by the end of this tutorial, you will have a solid understanding of the problem, the provided solution, and the underlying concepts. You will be equipped with the knowledge to tackle similar problems on your own and have a foundation to build up on for your journey into algorithmic problem solving. So, without further ado, let's dive into the fascinating world of removing duplicates from a sorted array and unlock the secrets to efficient and elegant solutions. Let's get started. The intuition behind this solution is to utilize the fact that the input array nums is sorted in non-decreasing order. By leveraging this property, we can efficiently remove duplicates in place without using any extra data structures. The two-pointer technique used in this solution is a common approach for solving problems that involve manipulating arrays or linked lists. The basic idea is to use two pointers to iterate through the array with one pointer, which is the slow pointer, tracking the position for placing unique elements, and the fast pointer scanning the array for duplicates. And here is a breakdown of the intuition behind the solution. First, we start with two pointers, I and j, initially set to 0 and 1. So I and j initially set to 0 and 1 respectively, and I represents the slow pointer, which points to the position where the next unique element will be placed. And j represents the fast pointer, which scans through the array to find duplicates. And secondly, we compare the elements at indices I and j. So if the elements at I and j are different, it means we have encountered a new unique element. In this case, we increment I to the next position and copy the unique element from index j to index I. And if the elements at I and j are the same, it means we have found a duplicate. And in this case, we continue moving the fast pointer j forward until we find the next unique element, or reach the end of the array. Thirdly, we repeat step 2 until the fast pointer j reaches the end of the array. At each step, we either skip duplicates by moving the fast pointer j forward or handle a new unique element by updating the slow pointer I and copying the unique element to the correct position. And finally, we return I plus 1 as the length of the unique element. Since I represents the last index of the unique elements, adding 1 gives us the count of unique elements in the modified array. The key intuition of this solution is that the array is sorted, which allows us to identify duplicates by comparing adjacent elements. By using 2 pointers, we can efficiently iterate through the array once and remove duplicates in place, maintaining the relative order of the unique elements. And please notice the code in here. The if not runs statement and checks if the array is empty. If it is empty, there are no duplicates to remove, so we can return 0. The time complexity of this solution is O of n, where n is the length of the input array nums. This is because we iterate through the array once using the fast pointer j. The number of iterations is directly proportional to the size of the input array, so the time complexity is linear. The space complexity of this solution is O of 1, which means it requires constant space. We perform the removal of duplicates in place, modifying the input array nums directly without using any additional data structures. Regardless of the size of the input array, the amount of extra space used remains constant, hence the constant space complexity. The solution does not create any new arrays, that dictionaries or other data structures that grow with the input size. It only uses a few variables, which are I, j, and the input array nums itself. So it uses those variables to keep track of the pointers and perform the removal in place. Therefore, the space complexity is considered constant. Understanding this solution will give you a good grasp of the basic logic and approach to solving similar problems. It's a fundamental concept that can be extended to other array manipulation problems as well. Alright, that's all for today. I hope this breakdown helps you in your learning journey. And remember, practice is crucial for mastering LeetCode problems. Please try solving more similar problems and gain familiarity with different techniques and data structures to enhance your problem-solving skills. I hope this was helpful. If you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye!